In 1997, Garry Kasparov was beaten by IBM's Watson in chess. Following this event, he invented Centaur chess, or advanced chess. In Centaur chess, a human plays together with a machine. We want to adopt the concept of a human playing together with a machine for design. Through designing together with a machine, designers and machine can work together to develop and conceptualize ideas for the 21st century.
Our project is to design a pavilion based on a biological role model, our biological role model being the curling of a leaf through the water movement inside the leaf, so osmosis, and we wanted to mimic that curling effect into a pavilion design. So the pavilion is going to be in Arup's office space, so we want to be creating a temporary area for the people in the office and potential clients who are going to be in the office space to be able to meet. When it's not being used as a meeting area, it can also be seen as an installation where people can be admiring the actual pavilion itself as an architectural piece. So the reason why we chose the leaf and the bending movement of a leaf is because the leaf is a structure which can be mimicked in architecture, and the actual structure and the turgidity of a leaf allows for the feeling of being enclosed in a space and creating a temporary space. And when the leaf becomes more rigid, it then expands, which creates more of an open plan feel. And we really liked the way that we could actually replicate that in an architectural office. So we felt that combining that biological mechanism with the built environment was a really smooth transition. And so we wanted to replicate that in the best of our ability. Arup has been fantastic in supporting us and inspiring us with our projects. So being able to work with an industry partner has been a great experience for us, as we've never had this opportunity before, and being able to work on an actual project which could be built was something that really inspired us to do well and to work hard with our projects. I feel like without that we may not have had the same drive, and being able to actually work with them and talk with the people at Arup meant that we were able to get some really good feedback and really improve our design. Collaborating with Arup, being able to bounce ideas off the representatives of Arup who came to our classes, and being able to suggest ideas and hear what they thought about our idea was really good, because it helps to get multiple opinions. And being able to hear someone who's actually been an engineer for a number of years and had some real world experience meant that it kind of gave us an extra edge on our design and helped to, as I said before, inspire us as designers and to come up with a really cool design. So this project has really helped open my eyes to the potential of working with neural networks, also looking at the biological role model and understanding the structures of leaves and how they move, and being able to replicate that in design, because I feel like in the future we're going to need to be doing more designs and be basing a lot more of our architecture on existing mechanisms from nature, as nature is the original designer and comes up with the most efficient solutions. And given the amount of gas emissions that are going out into the world at the moment from some of these buildings, requires that we're going to start needing to be designing smarter buildings and more energy efficient buildings, and using biomimicry in that, I feel like, is one of the solutions we can be using. So being able to have the experience of a group project has helped me a lot to be able to learn how to communicate better and more effectively and efficiently, to be able to communicate my ideas, but also to be able to discuss with others about their ideas, and to be able to learn how to be open and come up with new design solutions and really play around with the design process and play around with others around new ideas and testing and prototyping, and really understanding the design process from a group project aspect. So I found that really, really important to me going into the future, given that when in the design workplace, when working in industry, a lot of that time you're going to be working in groups, and I feel like having this experience really helps me going forward. Moving forward and furthering my research around this project, I'd want to definitely look into more specifically how I could translate the mechanism of a leaf curling into the built environment. There's a lot of different options, a lot of different prototyping that we did along that process. Obviously, because of the shortened time period, it meant that we were having to really fast track that section of the process, that prototyping section. But I think moving forward, I'd like to go back and do a bit more testing and do a bit more research around how that element could be translated. Because as I said, there are definitely multiple solutions and you can only come up with a final solution after doing multiple tests and prototypes. And I feel like going into the future, that'd be really effective to come up with an optimal design.
My group's idea was to translate the biomimicry of a plant, but more specifically a plant that responds to the temperature and the movement of the sun, and recreate that kinetic movement into our pavilion. The design of the flower is by replicating the curling motion of the petals themselves. So as it's responsive to the temperature, you get a horizontal or a vertical curvature of the petal. And it is this specific kinetic movement that we can implement into our pavilion or the built environment and get a specific response, for whatever the purpose it is that we may need. The reason that we have chosen this flower in particular is because from the very beginning, we wanted to look at the way that we can use the characteristics of the sun and the temperature and how they are independent of each other, and looking to see how we can translate this data set that it theoretically produces and then implement it into a kinetic or physical movement. The use of this kinetic mechanism is that not only can we create it from an aesthetic point of view or kind of like a personal interactive pavilion, but we can also think of ideas of how to generate or how to implement it in, for say, the built environment, or the possibilities are endless really. The beauty of this project is that we've looked into biomimicry, and biomimicry is that theory of that nature has had it right this whole time in design and in structure. And what's beautiful about that is that's something that we are striving, to accomplish in design itself, that we're going to need in the future to design more efficiently, optimize our structures better, the design itself more aesthetically pleasing. And you don't actually really understand how nature has even done this in a built environment perspective until you've done it yourself, until you've really put the effort into research. Going from what we did was a top-down approach by finding out the theoretical concepts of a biological role model, but then also thinking, hey, we're going to build a pavilion. And it's putting those two ideas together to really look forward into where we're going to be in the future with built environment in particularly, so in architecture as we understand it. Working with Arup has actually allowed us to put our foot in the door and understand what it's like to work at this new standard of what the industry is going to be expecting from us. Because at university, you're already striving for a high standard and to the standards of your tutor, but it's a lot different compared to when you're really going out there in the real world. And more specifically with Arup, they're such a large company, so we get to work with a range of teams that are within it. And within all those teams, you get all this constructive feedback. And it's this feedback that is really critical to understanding what is expected, where can we go from here, and really how we're going to end up with the final design. So it's through this course that we have been able to take this cutting edge technology and research and concepts we have done, and then marrying it with the leading industry professional work of Arup. And then hence we're able to reshape the built environment of what it's going to be in the future.